In 2015, 12.75 billion was invested in AI. In 2021, it was 93.5. That's a 633% increase, Shaheen. And it doesn't even take into account 2022. So
it was quite noteworthy that quantum hardware from Intel might just be expected this year.
Clearly what they're doing is encouraging programmers to begin building applications, coding software in advance of these systems coming online.
So we are gradually or rapidly getting to an iPhone moment in AI. Now, where I think this whole thing is going is to the enterprise, where you can get something like a ChatGPT, but then customize it to the particular vocabulary of your business and your customers.
We're seeing ARM increasingly showing up in elite leadership class systems, and it's less surprising each time it happens and less sort of exotic.
From Orion X in association with Inside HPC, this is the At HPC podcast. Join Shaheen Khan and Doug Black as they discuss supercomputing technologies and the applications, markets, and policies that shape them. Thank you for being with us.
Hey Shaheen, it's great to be with you again.
Great to be as usual. What is cooking today?
Well, just so much is going on, as it always is. It seems in our industry, a lot of mega trends. And we're seeing it obviously across the major topics driving HPC, AI, quantum, cloud, exascale, advanced chips, and it reaches up into the geopolitical realm as well. But I thought we could try to slot this in a little bit into your overall construct for advanced technology, advanced computing of the future. I thought it was a really interesting framework that I first heard from you 2 or 3 years ago, if you'd like to pick up.
Totally in agreement with you as a kid in the candy store from a technological standpoint, and just the magnitude and importance of the policies and the decisions that are being made at the global scene make this just such an interesting and important area. As you mentioned a few years ago, we were thinking about these big trends, mega trends, global transformations, and we were seeing that there's definitely computing going to the edge. So IoT, Internet of Things, was going to be a big play. And we did an episode on this, by the way, to our listeners, if you feel like it. It was one of our earlier episodes when we went through this whole framework. But the IoT would be the fountain of data, and then it needed to get communicated somehow. And that would be exemplified at that time by 5G technologies that are starting to become a little bit more mature, and talk of 6G and even 7G is out there. And then it needed to be made sense of, and that meant HPC and AI. It needed to be transacted. And some of the new activity over there was blockchain and cryptocurrencies. And of course, there's been a bit of a crypto winter, but that still carries on as a very important piece of technology. And then it needed to be accelerated, and GPUs would be an example of that. AI accelerators would be an example of that. And quantum computing would be an example of that. So that covers quite a bit of the landscape. It doesn't cover biotech and bioinformatics. You could argue that it may or may not cover things like fusion energy and space tech. These are all new frontiers, but no pun intended with the supercomputer, frontier technologies are really the name of the game.
Well, we're seeing these trends develop in real time, and because their impacts are so significant. When we make a nice little step forward on fusion or on quantum, this is important news. We're watching these things change and unfold before our eyes. It's amazing.
Yeah, so I think it's a pretty good idea for us to touch on 1, 2, 3 of them in each episode on a regular basis, because we track it daily. And sometimes new and noteworthy developments happen that provide a signal. And these signals are really important in analyzing how they end up impacting policy.
Yes, exactly. So, all right, why don't we jump in? Our first topic is about silicon photonics, optical I/O, and news from IR Labs, which is a startup partially funded by Intel. It's been invested in by HPE, and they have a development partnership with NVIDIA. But silicon photonics is one of those technologies that, if they can get the thing to work in a cost-effective way, could really have a profound impact on a lot of the way HPC is done, because moving data at the speed of light, essentially, not creating the heat problems and then therefore the power consumption problems that copper I/O or conventional I/O is causing these days. This really could change the face of HPC.
It sure can. And of course, maybe another way to manage our episodes is to go with the paper that Satoshi and Torsten wrote with the myths and legends, because some of these keep showing up there too. And it's aligned with that thought process. But absolutely, I think photonics, low power, high performance, totally a net new way to do things. And I think there's a lot of progress at the link level. With how am I going to maximize the throughput and minimize latency within one channel. But as we were talking pre-show, to do it cost effectively and to do it with a switch such that you can now expand it to the fabric, it seems to be yet to be done.
Yeah, we want to get more discussion on this technology. We do hear from the vendors. We want to put a spotlight on some of these problems that the technology that need to be overcome and look at it at a deeper level. But the news out of IR Labs this week is that they've announced the first demonstration of 4 terabytes per second bidirectional optical I/O. And they're playing that as a really significant advance in optical I/O. But, getting back to Satoshi's Myths and Legends paper, he said, the 2 big barriers for optical I/O is low cost, high volume manufacturing. And on that front, I think IR, for one, is making pretty impressive gains. But the other issue that I have not heard discussion of, aside from Satoshi, is on the switching problem. And right now, what he's saying is that silicon photonics is forcing adoption of circuit switching as opposed to optical switching. And circuit switching, he says, it causes a lot of complexity, a lot of latency issues. So again, Shaheen, this is a topic I'd like to hear more about.
Yeah.
And get to the bottom.
No, that he's right, of course. And circuit switching is how networks and fabrics operated traditionally until packet switching took over and provided more flexibility. Within circuit switching with photonics, it comes down to how you modulate these things. And there's amplitude and frequency and phase and space and wavelength. And you can, in fact, use the same channel more thoroughly because you're using signals with different wavelengths in this particular case. And therefore, they can operate in parallel without really noticing each other. But the thing with circuit switching is that you need to set the circuit up front. And once you do, it sort of stays in place. And it doesn't give you enough flexibility in how you want to go from point A to point B. And that could be a positive in some ways. It could be a negative in some ways. And it also turns it into the ongoing R&D project that it is.
Yeah. So right now, the market for optical I/O is really in its infancy. It's been estimated at about 5 million. But if they can overcome these issues, one firm projects it to be about a 2.3 billion industry within 10 years. So
that's an incredibly rapid rise.
Yeah, there we are.
But certainly, I think you can say that the market is going to be big. If maybe you don't believe it's 2, but it's still going to be big.
Yeah.
But it needs to work, and I think these guys are making progress towards it. Also, bigger picture, you sort of have electrons, and that's been the norm. But there's photons, atoms, there's ions, other particles and elements that you can use. And the reason I'm going down this path is we're going to see this show up all over again in the quantum computing world, how you're going to leverage the basic elements. So getting photonics right really is important. And it also has telecommunications implications. There's a whole large market there that actually reduces the cost of these things. You can operate at room temperature. It's got a lot of benefits if you get it right. There's also Avicenna Systems that is working on shorter range photonics on chip and chip to chip, although IR also talks about that kind of a connectivity. So these are all within a very small domain. They're not quite PCIe level interconnects yet. They're not InfiniBand layers. So they're kind of that hierarchy of networking. And then there's a company, Light Matter, that is working on photonics at the CPU level to do certain AI tasks faster. And that gets us into the mixed signal, analog plus digital renditions. And again, reminder of my 2x2, classical physics, quantum physics, digital technology, analog technology. Those permutations are really getting filled as time goes by.
Yes. Also under the rubric of chips, we have news again earlier this week that Fujitsu has delivered an ARM-based supercomputer to the Japan Meteorological Agency. This seems to be sort of a a sibling, if you will, of the Fugaku supercomputer, a lot of similarities. This system would come in at, looking at the most recent top 500 list from November, it would come in at about 14, whereas, of course, Fugaku is number 2 in the world. But I think it's interesting, Shaheen. We're seeing ARM increasingly showing up in elite supercomputing leadership class systems. And it's less surprising each time it happens and less sort of exotic.
Yeah, absolutely. So this is a not so mini Fugaku, because if it is that order of magnitude performance expected, that's pretty significant. And I look forward to getting more information on the size of it in reality. You're right that ARM is, especially with Graviton that Amazon has been doing, AWS, and with the Grace Hopper chipset that NVIDIA is doing and expected to finally unveil at their conference next month. Those are definitely coming and becoming a lot more of a norm.
All right, very good. Shall we move on to quantum news?
Yep.
Okay, so Intel announced this week their Quantum SDK, their software development kit. And looking over their announcement, I think you had some insights into other implications of that.
Yeah, I can't say it was like hidden in the announcement because it was like in the very first paragraph. But in the very first paragraph, they talk about their quantum hardware as well. They're talking about how this SDK is compatible with and dovetails with their so-called Horse Ridge 2 control chip that they announced back in 2019, which we kind of knew, but then also their quantum spin qubit chip this year. So those words this year makes this suddenly about really their hardware rather than the SDK. Now, the SDK is wonderful, and we can talk about it in a bit, but I thought it was quite noteworthy that quantum hardware from Intel might just be expected this year.
Yeah, and the other interesting thing, what they're talking about is full quantum computer simulation. And clearly what they're doing is encouraging programmers to begin building applications, coding software in advance of these systems coming online, building an Intel quantum ecosystem, if you will, with a software stack.
One thing that's happening with quantum computing that's different is that the applications are starting to show up, but there's no hardware to run it on.
Yeah, explain that to me, Shaheen.
Well, the hardwares are still experimental. They are in the noisy intermediate scale quantum NISQ era, where you have enough to kick the tires and do demonstrations and maybe occasionally run a kernel that looks very promising, but it's too small to run full-scale apps. But the apps are nevertheless being written because it's all software and you got development environments. So the SDK I kind of liken to a virtual quantum computer. Is that you've got the app, come run it on my virtual quantum computer, and because my SDK can be accelerated with my GPUs, in case of NVIDIA with their CUDA, quantum CUDA, and Intel with their quantum SDK, and there are others that have that. A bunch of the AI chip companies are also able to run quantum applications with varying degrees of fullness of simulation. So that's a really important thing, because if you've been spending the past couple of years building apps, you now have a place to run them. Now, you're not going to get quantum advantage, but in many ways, you kind of get good speed ups that beat the classical algorithm you were using before.
Right. So we know how quantum systems will run. We just can't build them to run yet, but we can build applications for quantum.
That's right. The applications are preceding the actual hardware in quantum land. Now, traditionally, it kind of is the other way around. You have the hardware and then you get busy writing apps and the apps lag it. In this case, they precede. Now, once you have real hardware, you're probably going to have to go rewrite some things or optimize some things. And by the way, there's a lot of progress being made in quantum technologies. There's a lot of depth that's being built into the supply chain and specific technologies, but they have not yet translated to a computer that can run real apps. And for those of you who listened to our last episode with Bob Cook of Quantinium and previously professor at Oxford, he was anticipating that in another 2 years or so, there would be real applications that could run with quantum advantage on their particular brand of quantum computer. And that's because they have visibility to that.
Yeah, that was one of the more optimistic forecasts I've heard, and very exciting. Now, one of the biggest problems in the quantum field is error correction. And Google, late in February, announced an advance in that field. They've experimentally demonstrated that by increasing the number of qubits, it's possible to reduce errors. And they're saying this is a pretty significant advance. They're saying a logical qubit that they made from 49 physical qubits was able to outperform one they made with 17 qubits. So this kind of reminds me of the big announcement from Livermore in regard to fusion. In the grand scheme of things, it's a pretty small advance, but any advance in error correction and qubit in quantum is extremely important.
Yep, I think you nailed it. That is a very good, significant, respectable advance, but it only shows that more experiments and more advances can now be made. And we still need significant progress in error correction. So I think the nice thing about their result was that they were able to show a way of error rates diminishing with additional qubits, not increasing linearly or superlinearly. So the sublinear growth was interesting and shows that they have some magic that can scale well. But, we're far away from hundreds of thousands or millions of qubits to run real applications.
Right. And moving on to one of our recurring and major topics, of course, is AI and what's being called the AI gold rush that's really been kicked off by ChatGPT, which kind of exploded on the scene in late November, and everybody's talking about. Bard has come out from Google, but a company called Writer Buddy, which I think is another generative AI company and application. And they set that application to do some research on investment in AI. And what they found is they announced that in 2015, 12.75 billion was invested in AI. In 2021, it was 93.5. That's a 633% increase, Shaheen.
Yeah, absolutely.
And it doesn't even take into account 2022. So, and if you look at the NVIDIA stock price, it's more than doubled since mid-October. And in fact, today, March 2nd, it went up 3% alone. So it's pretty amazing.
Yeah. Well, I think, we could have told them. But AI, of course, has emerged as the imperative of our age or our times. And when such advances as ChatGPT show up, where you are duly impressed, you don't expect it to do as well as it does, and then it does. You point out all sorts of things that it could do better, but nevertheless, it was a lot better than people expected it would be. And that is a watershed kind of a moment. So we are gradually or rapidly getting to an iPhone moment in AI, where this stuff is going to work more often than not, and it's going to be impressive. And in that context, the chip vendors leading with NVIDIA, but the others are not far behind. AMD is doing all manner of good work there, as does Intel, as does half a dozen other players, and then another 24 people behind them. And as we've discussed in our previous episodes, the thing with AI is that it promises a whole lot of killer apps. And then each of those killer apps is eligible to have infrastructure that is super optimized just for it. So that's why you get all these players in the market, because they take one sliver and go after it, and that sliver is going to be a big vein later.
Well, and just from an investment point of view, when an application like ChatGPT bursts on the scene and really becomes a major news event, it draws the interest of investors who aren't necessarily tech investors. So there's a greater pool of people that are really excited about this whole thing. So
very, very good point. Now, where I think this whole thing is going in terms of like real business and real revenue is to the enterprise, where you can get something like a ChatGPT, but then customize it to the particular vocabulary of your business and your customers. And it learns about your reality. So that is a really big opportunity. The other opportunity, it came up with the IoT world in the early days when General Electric had a digital twin of their jet engines and was using predictive analytics to decide when to do preemptive maintenance and such. And that can now be applied to other heavy asset processes inside your company and see how AI can reduce costs and improve efficiency and such. So all of that is really the driver behind the gold rush.
Yeah. And with generative AI, obviously it will generate commentary, it will generate results based on the data that it's drawing from. And in the case of this WriterBuddy.ai application and arriving at these investment numbers, it looks like it had a curated set of data from Crunchbase, NetBase Quid, S&P Capital IQ, and NFX. So in other words, they put together data from those sources as well as some others. And
Yeah.
so to your point, yeah, that you can customize the sources for that application according to your needs. So
Yeah, I think the interesting with the generative AI is that it can accelerate content creation as well as content consumption, summarization, reduction. So just today, there was an announcement that in Romania, they have a new, quote, cabinet member who is an AI that summarizes all the commentary and feedback that the populace has for the politicians. Kind of interesting.
yeah,
Now, you have to decide what the exposure for bias and all of that is, like how do you avoid bias? But it's coming. And then in terms of content creation, you could essentially create a movie based on prompts right now. You can get ChatGPT to do the script. You can get DALL-E to create the images. You can have another website, another AI do the voiceover with whatever accent and whatever. It's all there. And it absolutely is a watershed moment.
yeah. Maybe someday we'll all have our own customized movies based on what we enjoy watching. I don't know.
and then we want other people to look at it, but they want us to look at theirs.
Then a final piece on the systems end. This is news from mid-February, but I think it's worth noting, is success and progress with the tuning and the user readiness of the Frontier exascale system. And we found that they're running an application called EXA SMR, EXA, of course, for exascale, SMR for small modular reactor, nuclear reactor. And 86% of Frontier's more than 9,000 nodes are being engaged in running these simulations. So that's a significant advance on that front.
Very much, very much. There was also this conversation about the small modular reactors that is the subject of the simulation, but also one could see that in the future could very well be the way you power these things.
Well, Lisa Su at a San Francisco conference last week said supercomputers of the future will need their own nuclear power plants. And here they are, simulating a small modular plant.
Right, right.
So it all is kind of full circle sort of thing. So there we are. Okay, Shaheen, well, thanks so much. Great to be with you again, and we'll talk again soon.
Likewise. Thank you. Thank you, everybody, for listening. Until next time.
That's it for this episode of the At HPC podcast. Every episode is featured on InsideHPC.com and posted on OrionX.net. Use the comments section or tweet us with any questions or to propose topics of discussion. If you like the show, rate and review it on Apple Podcasts or wherever you listen. The At HPC podcast is a production of OrionX in association with Inside HPC. Thank you for listening.